Well, this
Okay, well,
is
I'm going to
my
go ahead
second
and
year.
start. I know your time is valuable, and I want to get through this as quickly as possible, but also give you plenty of time to ask any questions that I can make up answers to. Um, it should take us under an hour and a half, but I think it'll take at least an hour. But let me go ahead and share my screen to you. There it is. So go ahead and answer that. I want to know how many of you are in a full distance learning environment where students are never at the school, how many of you are in a hybrid, kids at the school some of the time, and how many of you are actually in a live classroom here. So go ahead and answer those. Okay, so that's an interesting blend. It's half and half, but nobody's back in a full live classroom yet. My district just started this. Are you guys seeing this poll or not? This is the first time I've done a poll. Are you guys seeing that?
Not the results yet.
Don't see it.
Let me go ahead and share that to you then. It's 50% of you are in full distance learning and 50% are in a hybrid situation, and no one is back in the classroom full-time with students at this point. My district just started yesterday back in the classroom full-time. So we're hoping that goes well. Up until now, they have been on full distance learning. But what I want to do is...
What's really interesting, I'm curious though, and I don't mean to interrupt, is that people are saying they are going from distant to hybrid. You said, next week. And I'm like going, how does that work in a district if parents don't want them to go back to school? I mean, that's one of why our MOU is through the end of December, because, it would be messing up the kids if they half distant, half, and they won't be in the same school even. Ours won't even be in the same school.
Different districts are taking different approaches to it. Some districts are like one of the districts here in town has half the kids show up Monday and Tuesday, half the kids show up Thursday and Friday, and everyone or Wednesday, Thursday, and all of the kids show up Friday. So every kid gets 3 days at school is the way they've done it to try to decrease the numbers. Interestingly, I have a friend back east, and her kids are in that kind of environment. The problem is one of her children is in primary grades and goes to school Monday and Tuesday. The other one's in upper grades and goes to school Wednesday and Thursday. So she can't go out and get a job. She has to be home with one of her children all week long. So it's such a difficult task for these schools to try to figure out. What my district did is they were on distant learning up until yesterday. And at that point, like my granddaughter's in 5th grade and they have 3 teachers in 5th grade. I think 2 of them went back to full inclusion classrooms, and the 3rd one is for parents who want to continue distance learning, who aren't comfortable sending their kids back yet. So distance learning is an option that parents can elect into in my district. I thought that was
How does that work for how does it work for the middle school where the kids change their periods?
Yeah, the school that I work at is small. Or that I worked at, I've been retired a couple of years, but I still go back there and do science once in a while. It's very small. There's only 2 8th grade teachers. One is language arts history, the other is math science. And I'm not sure if they're doing distance learning in middle grades or whether they're back in the classroom live. But what I wanted to share with you are strategies that are going to help you if you are in distance learning. And God help us, this might be something that isn't over in the near future. We might be revisiting this from time to time. Up here, we've had a lot of fires lately, and one of the schools went back to distance learning because of the smoke in the air. Now, I don't understand because there's smoke in the air everywhere up here, but it's kind of become the default go-to whenever there's a problem of any kind is send the kids back home. So I know this is a tremendous inconvenience on teachers. It's a tremendous inconvenience on parents, and the kids are struggling too. So what I want to do is share some things that hopefully will help you on this. So I'm going to go back and share my screen to you. And when we're doing distance learning, there's certain goals I want it to accomplish. The first is it should be something that I can push out to the student electronically, and they can give it back to me electronically as well. Now, my granddaughter, who's been on distance learning up to now, she's been receiving her assignments through Google Classroom and Google Meet. My grandson has to go in every 2 weeks and pick up a packet, has to physically pick up his materials. So we want to make this as easy on parents and students and teachers as possible. So we want to be able to submit it electronically to them. but also it would be ideal if it could be resubmitted the same way. For example, my granddaughter, when she does a page of math, her teacher has her hold the picture or the math page next to her face while taking a picture from her Chromebook and submitting that. So the teacher can see, yes, that's Tegan and that's her math work. But the pictures aren't great quality, and there's no way that teacher is actually able to look at that math page and see if it's being done correctly or check the work. She's often holding it upside down, or it's blurry or something like that. So the teacher doesn't know if the work is being done correctly. She's just giving a grade for completion. And fortunately, my granddaughter has a math teacher for a grandpa, so she knows when she's doing it correctly, but for many students, that's not the case. It would be nice if they could resubmit that and could actually be checked. So that's one of the things that I'm going to show you now. Also, I want this to be something where the child can work independently. We can't go to their homes and help them like we could in the classroom when they're struggling at their desk. Many of the parents are saying they can't help them with this. So it has to be something the child can work on independently. I want to maximize their learning, even though I'm minimizing my interaction with them. So that's the goal of that part. The third thing that I'm looking for in this type of work is that they can self-assess. If the teacher is not able to collect those papers and see if they're correct, I want the student to be able to self-assess. Now, there's a name I'm going to drop here that you might not recognize. His name is Stephen Marcy. Many of you have never heard of Stephen Marcy, but many of you probably use his materials. He's the author of the worksheet and workbooks called Middle School Math with Pizzazz, Algebra with Pizzazz, Punchline Math, and those kinds of things, where the student does a worksheet and the answers to the problems spell out the punchline to a riddle. And if the riddle is funny and the student gets it, they know they did their math right. Well, Stephen Marcy actually did his doctoral research in self-assessment. He's not just a bad joke teller. He actually has done his work on this. And what he discovered was when kids self-assess, as opposed to students who are assessed by their teachers, they tend to engage longer, they tend to make fewer mistakes, and they will repair their mistakes more than when a teacher has marked their assignment. So I want the student to know whether or not they're doing their math correctly. Now, what I'm going to show you today doesn't just apply to math. I'm going to use math as examples, but the types of activities I'm going to do, I'll show you how I created these. And this could be applied to any curricular area. And lastly, I want these to be something that builds a progression of skills over time. Now, I am really impressed with my grandkids' teachers and how they're able to just get through this season of our careers right now. My grandson's in kindergarten, and his teacher is able to keep him engaged and all the other kids in that class engaged on a computer screen for the full day. It blows my mind how she does that. But I also know that sometimes we're just scrambling to find work to give. For example, my granddaughter last week had a worksheet of 32 multi-digit long division problems that took her 2 hours. And as she's working on it, I'm thinking most of these kids in the class have no idea if they're even doing this correctly. And how much are they learning from 32 problems? Would 6 have been enough? So I want something that will not only occupy their time, but actually build a layering of skills to deeper and deeper levels over time. So that's what I'm going to be showing you. But first, I always like to keep my attendees abreast of the latest news. So I saw this in the newspaper today, so I'll give you a minute to read that. Very important article. And I apologize for my bad jokes, but get used to them because there's going to be a lot of them. Also, since we do have a small group, would you please unmute your mics if there's not like a jackhammer in the background, so that if you want to ask a question, since I'm screen sharing, I can't see your faces right now, and you just jump in at any time if you have a question or comment. So I'm going to show you 3 different math activities that I have done with my students back when I was teaching live that I've now reformatted for distance learning. And I'll show you later how that works. And I'll also show you how I made those. And I'm also going to give you 20 free files set up for distance learning based on these. So one of the things I used to do with my students was, and 1 second, my computer froze here. There we go. something called Foursquare Addition. Now, I love this worksheet. My kids enjoyed doing it. It was one of the things that engaged them in skills practice, but it wasn't formatted for distance learning. It was a worksheet that I ran off on the copier. Now, I'm going to show this at a very primary level, but it actually can be adapted clear up into algebra. And it starts like this. You put 4 numbers in the 4 squares. And the first thing the child does is add the top 2 numbers. In this case, we get 38. Then they add the bottom numbers, 17 and 31, and we get 48. Now we're going to add columns. 19 plus 17 is 36, and 19 plus 31 is 50. Next, I add these 2 numbers on the right, and I get 86, and these 2 numbers also make 86. Now, if these 2 numbers match, the child has done all the addition correctly. Now, when I do this in the classroom, I don't do this with numbers this easy for 8th grade. I use much more complex numbers, integers, things like that. But the first question my students ask me is, does this always work? And I said, I don't know. And then they say, well, can we try another? And I said, yes. Now, realize they've just done 1, 2, 3, 4, 5, 6 math problems. And the first thing out of their mouth is, can we do another? Because their brain wants to know if this was a fluke. So I put up a second problem, and it works. And I put up a third, and it works. And at this point, they're convinced that this will always work because there's a math theorem that says anytime something works 3 times, it works forever. They're convinced of that. So I said, but did you notice that it was me picking the numbers every time? I could have set this up. And then they say, well, can we pick our own numbers? I say, yes. So now they're wanting to do math on their own. So they put in their own numbers. My kids were always seated in groups of 4. So I told them, have each person in a group try a different set of 4 numbers and find out if it works. And at the end, they'd say, wow, it even works when we pick random numbers. And maybe one kid says, well, it doesn't work for mine. And then the other 3 kids in the group focus on his work to try to find out why it doesn't work. And they find out that he just made a math mistake. Now, if you're teaching students that are a little bit older, you might want to make it look like this, using decimals in maybe 5th or 6th grade. I add a cross, I add down, I add the right column and the left column, and they match. So it's self-assessing. Now, for my students, it looked like this, because my 8th graders needed practice with integers, but it still works with integers. So I found that probably half the mistakes my 8th graders made on a test or a homework assignment involved signed numbers. So I always gave them ongoing practice with integers throughout the year. Now, typically in textbooks, integer problems are not self-assessing. They're just going to add these up. They'll have no idea if they're right or wrong. And many of their intuitions about these kinds of numbers are not right. Now, I mentioned that one of the components I'm looking for is I want this to build skill over time. So once I've demonstrated this problem to a student, I could give them a worksheet and they could complete it. They would not need any more support from me. They wouldn't need any support from their parents, because this is an extremely simple process that they're going through. And as they're going through this, they're going to find out if they're doing it right or not. I don't need to correct this. I just simply need to record that they have done their work. It's self-assessing. If these 2 numbers don't match at the end, the average student is going to go back and try to find where the mistake is. So let me pause for just a moment before we continue. Are there any questions or comments that you have at this time? Go ahead and unmute your mics. And as I say, feel free to jump in at any point.
You mentioned that this could be used for algebra.
Mm-hmm.
Can you show us an example of that?
Yeah, I have a slide coming up that shows that.
Awesome.
Yeah. It can be used for anything that you're going to be adding. Anytime, if you wanted to add complex numbers in Algebra 2, you could do it this way. It would be a way to practice that skill. What's interesting to me about it too is every time a child does a problem, they've done 6 problems. Now, I give my students a worksheet that might have 6 of these 4 squares on it. And they go, oh, I only have 6 problems for homework. No, you've got 36, but they don't complain. And they tend to engage in this. They think it's kind of cool that it does this magical thing. And I have to convince them, math doesn't have magic. There's no tricks in math. Everything in math works for a reason. And later we're going to talk about why this does work, because that's one of the things I want my students to do, is understand the why behind something. Any other questions? Don't be easy on me. Okay, so, whoops, where did it go? Where did my, there it goes. Okay, you guys see my screen again? Are you guys seeing the Foursquare problem again? I want to make sure that I've shared it correctly.
No, we don't see it.
No, we just see your file.
Okay, let's see what's going on here. Okay, are you seeing it now?
No.
How about now? Whoop, no. Okay, hang on.
No.
I don't know why it's not coming through. How about now?
Nope.
Nope.
What is going on? Okay, I'm going to close it out and just restart the thing. Not sure why it's doing that. All right, let me see if I can make this work now. I am not sure why it's not showing.
Did you stop your share or did you pause your
No.
share?
Well, I'm stopped right now, but when I'm sharing it, it's not showing up as one of my potential screens that I can share for some reason. I don't know why. Okay, I'm going to try it a different way. You guys probably never have any problems with this kind of thing, right?
All
How
the
about
time.
now?
There you go. Yeah, we
Okay.
can see now.
It's weird. Okay, so the next thing I want to do is this. What if I give the students, you know, I've taught them this. It would take about 5 or 10 minutes to teach kids how to do this thing, right? So a few days later, I give them this worksheet. Now, do you see what we're doing here? This says Foursquare Addition, but is this still addition? What skill am I now having the kids practice?
Subtraction.
It's subtraction. And I don't have to reteach it, do I? I can build skills over time with this. So obviously on this top row, this number has to be what? It's 15 minus 8. That's got to be a 7. And 32 minus 12 is 20. I can now add this column, and then I can double check my answers. And there we go. So I can also work with subtraction on this. And I can do this with decimals. And I can do it with integers. Now this one's a little interesting because I only have one number here. I only have one number here. I could fill in this number, couldn't I? I can also fill in this number, couldn't I? What number has to go here? Make sure your mics are unmuted because I want this to be interactive. What number is going to go there? Thank you.
32.
And that makes this a negative number up here, doesn't it? And if that's -7, I add some number. When I increased it by 35, I'm at -7. Or to say it another way, -7 subtract 35 is that number. And I could complete this. Now I'm left with one cell. How do I self-assess this? Well, I could approach it this way 36 is changed into a 32. Oh, well, I subtracted 4. But -4 also works this way. So the student is always left with a way to double check that number. So I could do this with, it's still addition, but it's a missing add-in problem. So it still works. Now, if I wanted to, I could practice combining like terms. I have these binomials that I put in here, and I could figure out what binomials would go in the empty places. And then I could double check them. So I could use this as a way to practice skills in combining like terms in an algebra or a pre-algebra class. Now notice that all I had to do was teach that original problem of adding 4 positive numbers, and the student then knows how to do this. But I can develop this rich depth over time of these skills. So let's talk about why this works, because my students, once they realize no matter what I do, it always works, they want to know the why. So let's take a look at that. Oops, there it goes again. I always end up with these pictures of my grandkids in my workshops, and I don't know why the software keeps glitching like that. So I apologize. 4 grandkids born in 4 different states. What's the probability? That's a math problem. Okay, so what if we add these 2 numbers? What would go right here? Make sure those mics are unmuted.
A plus B.
Maybe
Thank you. What's going to go here?
C plus D.
Okay, and here?
A plus C.
And here.
B plus D.
Now, when I add this set of terms, I get A plus B plus C plus D. But when I add these, I get those same numbers, but the order has been commuted, or the associative property is used, depending on how you want to look at that. But the associative property and commutative property work with addition. So it's always going to work 100% of the time, no matter what kind of numbers you pick. You can use positive whole numbers with little kids. You can use decimals with older kids, integers, algebraic expressions. But with my 8th graders, I go through this algebraic proof so they can see this will work 100% of the time. Because I want my 8th graders to work with algebra, and I also want them to see proofs, because next year, when they move beyond algebra, they're going to be doing a lot of proofs in geometry. So, since this is based on the commutative property and the associative property, should it work if I try to multiply the 4 numbers? What do you think? If I seeded the 4 squares with 4 numbers and multiplied across and down, would I end up with the same products at the end? Well, inquiring minds want to know, so let's go back and find out. Okay, are you seeing this again now?
Yes.
Okay, so let's look at multiplication. This would be A times B. This would be C times D. This would be A times C and B times D. This would then be A times B times C times D, and this would be A times C times B times D. I've either commuted these 2 terms or I've associated these terms differently, but it's the same 4 factors giving us the same product. So you could use this for multiplication too. The only thing you want to be careful of is these numbers could start to get pretty big pretty fast. For example, if this is a single-digit number and that's a single-digit number, this was probably a 2-digit number. You're now multiplying 2-digit number by 2-digit number. So unless you hate your kids, don't put 3-digit numbers over here, because it's going to get real ugly really fast. So my question then is this. I always want to take these things and see if I can milk them for even more. So I'm going to go to another polling question. And let me see if where's my next polling question? There we go. Here comes a polling question. If I put those 4 numbers in and I subtracted across and then subtracted down, would I end up with matching totals? Since it's based on the commutative and associative properties which govern addition and multiplication, should this work with subtraction? Don't test it yet. Just tell me your opinion. So far, we have 3 that have answered, probably meaning the other people are trying to decide. They're trying to maybe test it. So just tell me if you think it would work based on the properties we've discussed. Okay, we have half of the people have responded. 1 says yes, 3 says no. I'll wait a little bit to see if anyone else wants to chime into the poll. And there is our poll results. You guys are seeing that now, correct?
Yep.
Yes.
Okay, because it's based on the commutative and associative properties, which work over addition and multiplication, this should not work if I try to apply subtraction. And a student once asked me this. He says, does it work for subtraction? I said, no, of course not. But let's look at what happens if I were to try that. Okay, so I did multiplication and proved that that works. You guys are seeing this screen now, correct?
Yes.
Good. All right, so let's look at subtraction. This would be A minus B, and this would be C minus D. Even if C is less than D, it's going to generate C minus D, which might be negative. A minus C would go here, and B minus D would go here. This expression would be A minus B minus the quantity of C minus D. This would be A minus C minus the quantity of B minus D. But when I look at those 2 expressions and I distribute the negative sign, I end up with this. In both cases, the A is positive, the B is negative, the C is negative, and the D is positive. When a student says, does it work for subtraction? I said no. And another student said, yes, it does, which blew my mind. It also works for division. So I can actually use this format to practice all 4 operations. It'd probably be difficult to set up a division problem because A would have to be divisible by B and by C. And A divided by B would have to be divisible by C divided by D, and so on. So it'd be very difficult probably to set one up, but you could use this for division if you wanted to. So this satisfies all the criteria that I wanted. It requires a minimum of instructional time for me and provides a maximum of independent practice for the student. It's self-assessing. It leads to deeper and deeper levels of understanding. And I'm going to show you how you can push this out to students electronically as a PDF that they can fill out and then send back to you. But I want to go now to another activity that does a similar thing. But first, you need another bad joke.
Yeah, that's pretty bad, but funny.
That's pretty bad. Okay, so many of you have seen this one before, especially if you've been following these webinars so far. It's called pyramid math, and it's another way I had my 8th graders practice integers. I start by putting 4 numbers in the bottom cells of a pyramid, and the students are told to add adjacent numbers like 3 plus 2 and write the number in the cell above. Now I have 2 and 7 adjacent, and so on. So I go through this, and I get to the top, and I have a 36. Now the child has just done 1, 2, 3, 4, 5, 6 problems. On the worksheet, I would provide the answers at the bottom. Somewhere on the bottom in the list of numbers, I'd have a 36. So the child can tell I got a 36, there's this 36 down here, I'll cross it off. If they don't get a 36, they go back and try to find their mistake. Also, in my answer banks, there's always some fake answers. Now, If I do a new pyramid, I would probably make it look like this for my 8th graders. They would have to practice with integers. And again, I could see this with decimals, and it still will run the same way. Once I've taught students how this works, they can work independently. I can also do subtraction by seating the numbers differently. But let's go back to the problem that we originally had. What would happen if I changed the order of these numbers that are being added? Should I still get a 36 at the top if I change their order? Well, again, we might say yes, because addition doesn't matter or order doesn't matter when we're adding. But look what happens if I take the 3 and 6 and I swap the 7 and the 2. Suddenly the numbers in here do become different. I get a 10 here, not a 5. And yet when I get to the top, I still get a 36. So let's put the 2 and 7 back where they belong and swap the 3 and the 6. Will I get new numbers in here that I've never seen before and still get a 36 up here? Well, in fact, I do get a 36, but I get numbers that I saw back in the first problem, or in the second problem. They're just a mirror image, and the reason is because these numbers are mirror images to start with. Now let's do this a 4th time, and I'll put all the numbers in the wrong order. Instead of 3, 2, 7, 6, I'll put them backwards. And I still get a 36. Now, at this point, I typically ask my students, how many different ways can I arrange these numbers down here and still get a 36? So they start thinking about combinations and permutations. How many different arrangements can I take with these 4 digits that will create a number 36 at the top? And they start trying them. Maybe they try this one. Same numbers, 3, 2, 7, and 6. And they add their way to the top. And they find out they've made a mistake. So they'll typically erase those numbers and start over. Can you find the mistake in that pyramid? And it turns out that 2 plus 3 is 5, 3 and 7 is 10, 7 and 6 is 13. These two do make 23, that's 15, and that does make a 38. And for some reason, changing the order of addition created a different sum up here. And this really engages the human brain when this happens. My students, as I said, will erase this and redo their math. So they're doing their math twice now, which is even better than doing it once. And I have them put them in a different arrangement and add their way to the top, and they get another number. And again, I would have these answers at the bottom of the worksheet in order for them to find out if they're doing their math correctly. So let's take a minute to find out why this is working. But before we do that, let's make an exploration here. I started with 3, 2, 7, 6. What would happen if I went 3, 2, 7, 7? What would adding 1 do to that top number? Will it add 1 and give us a 37? Or will it add 1, 2, 3 as we move up the lines? So my students test their conjectures, and they find out it adds 1. And I say, well, let's try it again to make sure it's consistent. Instead of 3, 2, 7, 6, let's do 3, 2, 8, 6. And then they find that it doesn't add 1. It added 3 from the 36. And by this point, they're very confused, and their brain wants to know why it works this way. So then I have them do this problem. This cell would contain A plus B. This would contain B plus C. This would contain C and D. This one would be A and 2 B's and a C. This would be B, 2 C's and a D. And the top will have an A, 3 B's, 3 C's, and a D. If I swap the A and the D, that expression doesn't change. If I swap the C and the D, it doesn't change. But if I swap the variables A and B, I now have 3 A's but only 1 B, and that will affect the answer. And adding 1 to this term will only add 1 to the expression, but adding 1 to that term will add 3 to it. So now they understand the algebra behind it. And again, I can put binomials in here. I can put any type of number I want, and I can use this for both addition and for subtraction. So any questions, comments so far on these two? Don't be shy. Alrighty, well, I'm going to go back and show you one more activity that we can do this way. And another bad joke. So X marks the spot is another activity I do with my students, and it works like this. I give them two numbers. They have to write the product of these numbers up in the ceiling and the sum of the numbers in the basement. Now again, with my students, I would not use the numbers 3 and 4. With older students, I would use decimals. And with older students, I would use integers. This is going to be a -12 for a product up in the ceiling and a -1 in the basement. I could also put in monomials if I wanted. 3x times 4x gives me 12x squared, and 3x plus 4x is 7x. So now they're multiplying monomials and combining like terms. Once I've taught them how this works, I no longer need instruction. They can continue to practice this, even if I do something strange like this. Now, in this case, I am subtracting, because this is supposed to be the sum of the left and right numbers. So 8 plus something is 3. Well, that must be a -5, and now I can find the product. So now I'm doing subtraction and multiplication. But I can also do division and addition. So I can practice all 4 operations with this skill. And it's very simple, and the students can understand it. They don't need any additional instruction. But it's a rather engaging way to get skills practice in. I can also do this, -24 on the ceiling, -5 in the basement. I need numbers that add up to -5, but they multiply to -24. So I start thinking about the factors of those numbers, and eventually I stumble on a solution that gives me a sum of -5 and a product of -24. So as they're doing this, I can then use this when I get into factoring. Now, I call this the ceiling. But I did that because I want them to think of putting the C term there. And the basement is where the B term is held. So when I put those two in, I now am looking for these numbers that multiply to -12 and add up to +4. And it's those two which gives me the factorization. I can then take this principle and introduce it into very complex polynomial factoring. So again, this was the basement, which is 13. But up here, I've been calling this the ceiling, but there's something else in the house that's upstairs behind this, besides the ceiling, and that is the attic. So attic times ceiling would be 6 times -5, -30. Now I need to know how to solve these two. This turns out to be 15 and -2 add up to 13 and multiply to -30. Now the A term goes there, the C term goes there, and the B term will come from here, and it's these two pieces here. So I put in 15x and -2x. I then factor the columns and factor the rows, kind of like when I was using multiplication earlier in Foursquare. So this has 2x as a factor, +5, 3x as a factor this way, and this has simply 1 as a factor, but the lead term is negative, so I'm going to make it a -1, and there's my factorization. Now, I know I'm blasting through these examples, but the handout that's going to be available to you has way more examples and reiterates what I'm talking about here. Let me stop the screen share for a minute and see if there's any questions on that activity. And then I want to show you how I made these. Any questions or comments so far? You guys are being too easy on me. Okay, so let me see. I think what I'll do next is take you in and show you how I'm making these. And then I will take you back and get you to the handouts on it. So I'm going to screen share again. And the PDFs that I'm going to give you are made through PDF Escape. And I'm going to show you how I did that. So the first thing I'm going to do is screen share, and I'm going to go back to this. Let me get this out of the way if I can. I'll just do it this way. So PDF Escape works like this. Simply pdfescape.com. I'm going to give you a link to this later on. But what you're going to do, first of all, is upload a PDF file. Now, there's tutorials online about how to create PDFs if you don't have them. But let's say you have your favorite worksheet. You just absolutely love this worksheet, but it's a physical copy. And you want to make it into something that can be submitted electronically to the students and then back to you. Most copy machines now will turn those into PDFs. They will scan them and send them to your desktop so that you have a PDF of it. You can also get apps for your phone that will take a picture of it and convert it to a PDF. But what I'm going to do is just pick out a Word file that I have on my computer here. And I think I have one in this folder. Oops, first of all, I got to go get that and make it a PDF. Okay, so this is an activity I've done with my students called Leo's pattern. And it's based on Leonardo Fibonacci's sequence, where you take two numbers and add them together to get the third number. So 5 and -2 is 3, -2 and 3 is 1, and so on. So the first thing I'm going to do is get this full screen here. And I'm going to take a picture of it. Let me get it a little bit bigger. On Mac, I'm simply hitting Command-Shift-4. And that allows me to capture a screenshot of that. And I'm going to be using that screenshot a little later for a second one. But right now what I want to do is turn this Word document into a PDF. So you can do that through the print command on a Mac. With a PC, it's different, because you're going to simply go PDF, save as PDF. And I'm going to save it to my desktop for now. So that is no longer an editable document as a PDF. Okay, and then I'm going to go to Choose File, and I'll grab that off my desktop. There's Leo's pattern PDF. And it's going to do this. And has anybody ever used this before? Unmute your mic if you have. Probably most teachers use Google Forms when they want to create an assignment for electronic submission. But I like this because I can take something that's a physical copy and turn it into an editable PDF. So you're going to click Form Field. There's lots of different things you can do in here, but I'm going to keep it simple. You're going to click Form Field and hit Select. It comes up as text, but you have other options and you want text. Select, and you simply draw a box. So now that's where the kid's name will go. If I right-click that and go to Object Properties, I'm going to select Required. Now the child cannot turn this in unless they put their name on it. Ta-da! I will then right-click it and hit Duplicate, and I will move that down to the date and resize it so it fits in that blank. You can also change the font size of these if you want to. I'll duplicate it so the child can put in the period that they're going to be in, first period, second period, whatever. Now I'll duplicate that, and I'll start putting those into these blanks. Now, once that's done, unfortunately, the free version is not the fastest thing I've ever used in my life. You have to do each one of these. One of the nice things about it, though, is if the student is tabbing in between, it will go through them in order. The very first blank they come to is put your name in, and then the other one. So you want to set these up in the order you want the child to do it. But you'd simply put one of these in each of the places, and this is where they'd have their answers. When you're done, you're going to click Save over here on the left side, and then you can click Download. It's now my download folder. I'm going to pull it out and open it up. And you'll see that it has these fillable spots. In fact, if I put in here, me, I hit tab today, I hit tab period 1, I hit tab, those two add up to +1, those two add up to 4, and those two add up to 5. And you can see I didn't line those up really well. I'm using a font that's too small, but that's now an editable PDF that they can fill out. And if they try to resubmit it with one of these blank, it's not going to allow it. They can't continue. So that's PDF escape. And I'm going to give you 20 different activities based on Foursquare Addition, pyramid math, and X marks the spot that are already made up for you. So that's how that works. Any questions about that particular platform? Have any of you used that one?
No, I've never seen it before.
Okay.
No, that's new to me. I love it.
Yeah, it's free. My main complaint against it is it's very time consuming. My next month's webinar is on integrating fractions, decimal, and percent representations in an area model. And one of the activities I had to make a 10 by 12 table that could have numbers in it. I had to put 120 of those little boxes in there. So it's very time consuming. But once it's done, and you've got it for life. So it's not the most fluid way to do it. There is a paid version. I'm assuming that would give you lots of options, like maybe aligning those boxes or something like that, so they weren't kind of random across my rows and things like that. And maybe there's a way to do a group duplicate. So once you have a line done, you could duplicate that whole line and move it down. I don't know. I've not explored the paid version, but it comes out pretty clean, and it's a really nice way to take an existing worksheet. If you're, a social studies teacher and you want to do state capitals, you can put a blank in each state. The kid has to put the capital in there, and then it's done. So that's one way that I've been making these worksheets. If you joined me last month in August or back in July, I gave you guys some fillable PDFs, and they were created this way. A bit time consuming, but it comes out, I think, looking very professional, and I really like it. Now, the other day I saw another strategy that I have not been using, but I went and tried it, and it's very clean. I think it would really work well for you guys where you're dealing with older students, and it's based on simply Google Slides. And the students can do a lot of the work. So I'm going to show you a second way that I can take that same worksheet and turn it into a fillable document. And it's one that I'll show you how I do this for younger kids, and also how you can do this for older kids. So for this one, let me go back and share my screen again. And I am now going to go to, let's see, what do I want to do here? I want to go to Google Slides. Are you guys seeing this?
Yes.
Okay, so I'm going to open up a blank slide. Now, the first thing I'm going to do is I'm going to get rid of this stuff. I don't need this anymore. I just want a blank. I'm going to go to background. Oops, no, I'm not going to go to background. I lied. I'm going to go to, is it layout? Nope, it is. I'll edit.
You're right, it is in the background.
I wanted to go to something else. I want to change my page to, is it down here? Page setup. Yep, go to page setup. It's set up to widescreen, but I don't want to do that. I want to go to custom and make it 8.5 by 11. Why would I do that? Because I have a worksheet that's an 8.5 by 11 inch piece of paper that I want to bring in. Now, what I'm going to do is go back to this document. Remember when I took a picture of this? So that's not a PDF. Okay, oops, that's the wrong one. This one here. So this is simply a screenshot of that document. Okay, and this happens to come in as, I think, a PNG. This is going to want JPEG and PNG. So this is an image now. And I want to place this image into the document. And you might think, well, you're going to click image, but you don't. Because if you click image, the moment the student clicks on it, it wiggles around. So I'm going to go to background, change the background to an image, choose an image, and that should be on my desktop, and it's my screenshot. And what it does is it now looks like this. If the student clicks on it, it doesn't move because it's part of the built-in background of the page. Now what I want to do is this. I'm going to zoom in a bit, quite a bit, and I'm going to go over here, and I want to put in a text box. So insert, text box, and I'm going to put it right here. I want another text box right here for the date. Now there's a problem with this. When I do this one, the other one disappears. So with older students like upper middle school, high school, they can put in their own text box here. They don't need you to do this. You just send them out this page with a worksheet built into the background. And you could train them. This is how you're going to fill in answers. And don't forget to put your name on it. Now, that original text box in the name is still there. But until you click on it, you don't know it's there. It's invisible. So with younger kids, there's a couple of options. One is you could put some text in there. You can put an answer, you can put in a question mark, and that's a clue to the kid that there is a box there and they need to replace that with their answer. So you could do that. Now another option though would be to do this. When you first create the text box, let me delete that one, and it comes out blank. Go to fill and put some color in it. And now the child knows that I'm supposed to put something there. I could then duplicate that if I wanted. And then I can move it down here. And I could do that again. And I'll shrink this one quite a bit. In fact, I'll shrink it so much that once I duplicate it, it becomes the one that I'll put here. Now, one of the things I like about this is, as I say, the older students can do some of this work for you. You don't need to put in all these boxes, but you could if you wanted to. Also, I can do a multiple select, of course, here. And now I've done the whole row. And you can change the font sizes for these text boxes or the fonts themselves and that kind of thing. You can also, let's say that I put these in here. And it's locking up on me here. Come on, there we go. Let's say that I don't have them lined up. You can do this, and then you go to Arrange, Distribute, Horizontally, Arrange, Align, Top, and now they look like you're really a professional. So you get more editing options this way, and I think it's a nice one. It doesn't have the advantage that the student is just tabbing through these though. For example, when you put your name in here and hit tab, it doesn't take you to date in class. You can't make these required cells, but I think it's a really nice way of pushing this out to the kids. Especially I notice most of you are teaching middle school and high school. You could just send them out this paper on the background or this page with the background and have them, when it's in Google Classroom, make a copy and then they edit that copy. So when you share it, make sure you share it so that they have to make a copy. They're not editing your actual document. So that's another way that you can make these guys. Any questions or comments on that? Has anyone tried that strategy before?
Oh, I
Yeah,
like that.
I use it in my classroom.
Yeah.
I do.
And tell us about it. How'd that go?
It's good, but like you said, I mean, it's time consuming though. And I don't give my kids very many problems, the ones that are online. I have about 25% of my kids online and the rest of them are in class.
Yeah.
It's time consuming though.
Yes, yes, it is. And you know, you're kind of caught in this thing. Do I invest the time in this if the kids are going to be back in a month? Well, what if they're not back in a year? Or if this becomes the new normal for education, then it's nice to have these, you know, in your pocket.
Exactly.
And like I say, I'm going to give you 20 of these that I've already made up. I don't have a life, so I just sat there and made a whole bunch of these. So you're going to get 20 of them for free.
You're so funny, Fred.
And again, I like that second one because, you know, as an 8th grade teacher, I could teach my kids the technology and then they could do that. And I don't think we teach enough technology in schools nowadays. You know, when I mentioned that my granddaughter got 32 long division math problems to do, it's not a skill she will ever need in a job. There's many skills in technology that she would have, could have better invested her time in. And so I think kids could be taught to do this. Let's do this. Any other questions or comments before I go back and get you your materials that I'm giving to you and maybe do another bad joke or two? Well, you guys are the nicest audience I've had all day. Okay, so let me go back to here and let's get you another bad joke. Now, I assume that most of you are already on my newsletter. If you're not, this is how you can sign up for it. And some people are finding that they prefer to use their personal email because schools often filter it and it comes in as spam because I'm sending you links. But if your school, if you've been getting these at school, that's fine. Feel free to share this with others too. I mentioned last month during the webinar that the more people I have that are subscribed to my newsletter, the less I need to charge when I do, when I'm getting materials out to people or doing a paid webinar. If I'm doing a webinar for one person or 100 people, it's the same price to me. So I would rather distribute that as much as possible. So if you have colleagues who are not subscribed to my newsletter, send a link over to them, see if they want to join. Also, when you go to my website, check the resources tab, best place to go. I flipped my classroom the last 2 years, so I have videos for 8th grade math. I have solving equations, working with functions. All my science labs and all my curriculum is there in very short videos that can be sent out to students as links. So that will help you with distance learning as well. Also, never skip the free resources tab. Don't go to my store until you've checked that because you don't want to buy something that is free. If you are interested in having me do a workshop for your school or your district, don't hesitate to get a hold of me. I'll be more than happy to do that. And also, if you're subscribed to me on social media, I'll let you know when I have something new going on. So also on the website, if you go to the professional development tab and hit workshops and seminars, the last 2 free webinars are still there. I'm going to be uploading this webinar. I'll be kicking this one out and replacing it with this one. But these 2 webinars are still on there. This was August and this was July. So if you're interested in either of those and missed them, it's free to watch them for now until they get kicked off. Okay, so you got that one, you got that one. And also the 3 handouts, Foursquare Addition, Pyramid Math, and X Marks the Spot are normally $5 each. I've dropped them down so you'll spend $9.99 if you want to buy all 3 or buy one of them. And they have worksheets already made up. You could then scan those and put them into a fillable PDF format. I want to mention too, I should have mentioned it earlier, be very cautious when you do make an image of something and convert it to something electronic like that. Watch for copyright issues. Like my activities, the copyright says you can make copies of these for your students. So it's perfectly okay to make an electronic copy that you convert to a PDF and send out to your students. But like a textbook doesn't have that kind of a license. And as we send these things out electronically, technically, anytime you set a textbook on a copy machine, it's a copyright violation. Once that goes out to a student, if they then share it, it could get ugly. So be very careful when you're making a copy of something. Think about whether or not you have permission to do that. Obviously you do with this stuff that I'm giving you, but be very cautious. If you got a worksheet from some book long ago, making an electronic copy of it may not be legal, and I wouldn't want you to get in trouble over something like that. So just be very cautious. I'm going to give you the links. Let me pull out of this for just a second. I'm going to give you these links in the chat box. Stop the share long enough to go over to the chat box. So you have a link to my website. Looks like that one didn't come through as a link for some reason. I don't know why. I wonder if I can convert it. Nope. So there's my website. To subscribe to my newsletter, click that one. To go to the store, where I have over 100 products there, there's my website. And this is your handouts. And I'm going to show you what those look like right now. So you might want to copy that, save it for a second, because we're going to pop out of this window for just a moment. I'll bring you back here in a minute. But I want to finish up this. So this is what it's going to look like when you go to that link. You're going to get Foursquare Addition as a fillable PDF. There's one copy of that. If you want the handout for $3.33, it's right there. I have 11 copies of Pyramid Math, everything from simple single-digit addition up into decimals and integers, and also where they're arranged so that kids are subtracting. There's 11 different ones. There's one with binomials already made up. There's 11 of those. Those are free. This is the handout. I have 8 of them made up already for X marks the spot. So that's a total of 20 free PDF files, and that's the handout. This link will take you to a YouTube tutorial on how to use PDF Escape. This one will take you how to use Google Slides. So if you forgot anything I said, these 2 links are people who are smarter than me that will tell you how to use those 2 platforms. So this is what those will look like. That's the Foursquare Math one. And you can see these will show up as blue fields that the kids fill in. So what you do is you'd put in numbers here for the kids, and then you'd send that worksheet out to them, and they would fill it out. And that's that link that I gave you. If you want to take a picture of that with your phone, I'll leave that slide up for just one moment. But it's also in the chat box. And I want to thank you for joining me. Next month, we're going to be doing an activity called Integrating Fractions, Decimals, and Percents with Geometry. The dates for that will be October 20 and 24. That's a Tuesday and a Saturday. And again, we'll offer 2 time slots on Tuesday at 1 and 4, and Saturday will be in the morning at 10 a.m. That will be my first paid webinar. It's going to cost the price of a cup of coffee. It's $5. And I'm going to then give you a link that will allow you to download the handout, which is a $4.99 handout. You'll be able to download it for free. So essentially, this will cost you a penny. But when you get the email, the information for that will go out on the 1st of October, the registration information. It will take you to a page that says, buy a cup of coffee for $5. You click that, and then you click a registration link, and that will take you through to that. So I am going to back out of this and find out if there's any other questions or comments that you have. As we close, if anybody wants to stay online to ask me a question or something like that, I'll stay here until the last person checks out. But any questions or thoughts or comments that you want to share?
Thank you.
It's my pleasure. Thank you guys for what you're doing. I mean, like I say, I retired before the bomb went off. And I'm amazed at what you guys are doing. I was telling an administrator recently that there is no other profession that could have pulled this off. I mean, our teachers in our district found out a week before school started that they would have to switch to online. They had the classrooms all set up. They had 1 week to prepare, and they did a fantastic job. I mean, if you gave teachers a roll of duct tape, we could put someone on Mars. We are the MacGyvers of,
Yes.
of the career world. So let me know if you have any questions, and I'll stick around. But thanks you guys for coming in.
That's pretty awesome. I sent you a message about the Tim. So
I saw that. Thank you.
And then awesome. So yay. Thank you very much. This was great. And I like the way you converted. I'm going to show teachers how to do all of that. So
Good, good.
That's pretty awesome. Thank you.
Thank you
care.
much. Thank you, Jenny.
So I wanted to ask, I work for Riverside County Office of Ed,
Mhm.
and I haven't done an X marks the spot since like on an Excel sheet where it would generate the numbers, and I did not use it in all the fashions that you did. And I wanted to know if I share any of this, not share like give them a copy, but share the strategies. Is that okay? And then send them to like your store as to where I learned
Yeah. Yeah.
your
This,
math and.
yeah, I'm recording this training. I should have mentioned that to everybody. I'm recording the training. I will upload it to my website so anybody could watch it for free. And it'll be up there for about a
Okay.
month or two. And then after that, they would have to pay. So have them check that. They can watch those for free. They can download
Okay.
those handouts for free. The other ones they would
Okay.
have to pay. And so
Perfect.
like if they said, I really like pyramid math, I'm going to buy that handout. They can buy it. And then the pages inside, if they wanted to make copies of that as PDFs for their students, the copyright release in the book allows for that. You can make as many copies as you want for your own students. You just can't make a copy of the book for somebody else.
Yeah, fair.
No
Okay,
problem at all.
great. Thank you so much. It was awesome. Thank you.
Thank you, Karen. Take care.
You too.
Bye.